Hello everybody, I'm Dr. Magali Picard and welcome back to the complete educational program video proposed by Demptos Corporate in its Design My Barrel offer. So today I will talk in more details about the spirit aging bouquet and more precisely about the evolution of aromas during the spirit maturation. Aged spirit is a complex mixture of hundreds of flavor compounds in an ethanol water matrix. So these compounds originate from the cellular raw material, the individual production stage of starch conversion, the fermentation and distillation, and finally the aging process in oak barrels. The maturation step can be considered as replacement of soapy, pungent, metallic, sour and harsh notes with a smoother, matured and mayonnaise attribute. A range of physical and chemical interaction take place between the barrel, the surrounding atmosphere and the maturing spirit, which transform the molecular composition of the spirits and give it more complexity. The impact of oak wood on the distillate is decomposed on three kinds of maturation phenomena: the subtraction, the addition and the interaction. The subtractive maturation corresponds to the loss or suppression of aroma compounds. Low and medium boiling point sulfur compounds, which give unpleasant aromas of cabbage, are removed from the distillate either by the charring through their absorption on the charcoal layer or their oxidation into sulfoxides by elagitanins. Acidity increases with time during maturation, principally from the acetic groups of hemicellulose, leading to acetic acid and a significant decrease of the pH. This leads to the protonation of pyridines, which are basic compounds responsible to fishy and solvent notes. Acidity thereby lowers their volatility and their aroma impact in the matured spirit. The additive maturations refer to the direct extraction of wood aroma compounds. A large palette of roasted aromas is thus transferred from wood to spirit over aging, thanks to many processes occurred in the wood with the formation of aroma compounds during its treatment followed by their ethanol extraction, and in the hydroalcoholic phase with lignin, which is firstly extracted by ethanol to yield ethanol-lignin compounds, which are further degraded into simple phenolic compounds in spirits. Most vanillin and cyrangaldehydes with vanilla and wood aromas are generated after the oxidation of coniferaldehydes and synapaldehydes. The presence of oxygen in the mild acidity of the medium, mainly modulated by the increase of acetic acid content over time, favor this pathway. The amount of total whiskey lactons and thus the coconut aroma perception in matured spirit increase over the maturation period. A high excess for the cis whiskey lacton is also observed in spirits matured in American oak casks, leading to a higher intensity of this aromatic descriptor. The maturation step also increases the content of pyrazines and pyrols in spirits by transferring them from the oak wood barrel to the raw distillates and thus enhancing the roasted character of matured spirit. The richness of carotenoids in oak wood is also an important factor when selecting wood for cask. Indeed, when wood is exposed to light and oxidation during natural seasoning and then to heat treatment during the toasting process, carotenoids are degraded into no-rhizoprenoids. These new aromatic compounds offer pleasant spicy and floral notes and are easily transferred to whiskey during the maturation. Finally, the interaction maturations correspond to various interactions occurred between the wood and the distillate. Such reactions are typified by esterification. A large part of this is due to the formation of ethyl acetate from acetic acid, either extracted from the cask wood or the product of ethanol oxidation. The presence of the large excess of ethanol favors the formation of ethyl esters by transesterifications, resulting in a significant increase of the fruity notes in the matured spirit. Moreover, Aromatic acids extracted from the cask wood, such as syringic and vanillic acids, are also known to form ethyl esters during the maturation, namely ethyl syringate and ethyl vanillate with more creamy notes. So overall, the increase in the diversity and quantity of esters during the maturation is believed to influence the quality of the aroma, producing a more blended effect. Finally, the pH decrease over maturation due to the presence of acetic acid given by the wood allows molecular transformation of terpenes compounds. Terpenols found in the distillates, such as linalol, is changed into other terpenes, enhancing the diversity of floral nuances in the matured spirits. The complexity of spirit aroma is not the result of any single dominant compound that would confer a specific aroma or a particular character, but to a multitude of components. The diversity of sensory perceptions results from qualitative and quantitative perceptual interactions between odorants. Thus, the amount of a volatile component is not sufficient to tell how much a particular compound contributes to the overall aroma perception. For example, although alcohol are the main aroma components of whiskey, their contribution is rather low, accounting to about 10% of the overall odor intensity. On the contrary, esters and aldehydes are found in lower concentrations, but contribute up to 80% of the overall aromas. This does not mean that these components alone can create the Amadeus Milo aroma of whiskey, but their contribution to aroma intensity is considerable. And this complexity thereby increases over aging upon wood, since upper content of aldehydes and esters compounds are found in matured whiskey. So, thanks everybody for watching this training video about the development of the spirit aging bouquet over aging. You can find all the most important information in the Design My Barrel reference handbook. And in the next video, I will talk in more details about the qualitative evolution of the taste and colors in the matured spirits. So, see you!